Auzu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Dear students, today another very important topic. That one is the Doppler effect. The chapter number 8 related to the sound. So today we will go through Doppler effects. Whenever there is a relative motion between a source of a sound and a listener, the frequency of the sound apparently changes. This effect was first studied by Australian physicist C.J. Doppler, and this phenomena is known as Doppler's effect. So when we go to explain this statement, the apparent change in a frequency, before to write the definition or the statement of this effect, when the sound is being produced by our object, just I'm teaching you, I'm producing the sound, so I'm a source of the sound. And you students are listening my sound. So you are known as a listener or observer. If I'm producing a sound, I'm a source of the sound, you are listening, and if you move towards me, you will hear the louder sounds, more frequency. Even the sound that is being produced have the same frequency, but you perceive the more frequency when you are coming towards the source. Or when you people, means observer is moving away, then the frequency observed by the listener will be less, decreasing. In a same pattern, when you are in the rest, and myself, I am moving towards you, so that means the frequency apparently increase. But when move away from you, that will apparently decrease. So this phenomena, because of the relative motion of the observer or source, there is a change in a apparent frequency, not in actual frequency. Actual frequency of the sound will remain same, but the frequency observed by the listener, that will appear to be changed. That frequency is known as the apparent frequency. Let's suppose this one is a source that's a producing sound, and observer is over here. This one is observer. The sound is produced by this source, observed by this observer. Whatever the frequency is produced by the sound, if they both are in the rest, the same frequency will be observed by that one. Let's suppose its frequency is 20 hertz. When the observer and the source both are in a rest, then the observer will receive the frequency that would be 20 hertz as well. So this one is apparent frequency, and the actual frequency will be same when the observer is in the rest. But let's suppose if the source, this source, is in the rest, producing the sound of the frequency 20 hertz again, and if this observer is moving with a velocity v0 towards the source, then you know what happens? The perceived frequency, even the frequency of the sound is the 20 hertz, but the frequency observed by this observer will be more than that one. That means it may be, the apparent frequency may be 21, 22, 23, whatever be. That means that would be greater than the actual frequency when it's coming towards. So this one is an apparent change. It's more than the 20. This is the apparent frequency, which may be greater or maybe less. Or let's suppose, again if you go through this, the sound is being produced, and your observer this observer is going away with a velocity v naught, away from the source. The source having the frequency, let's suppose again 20 hertz, same frequency. Frequency of the sound is the same. But because of the motion of the observer when it's moving away from that source, the apparent frequency will decrease. So this one is one case that when there is a slight change in a frequency due to the motion of the observer, that effect is known as Doppler effect. In a same way, when we talk about the source is moving, let's suppose now observer is in the rest. Now observer in the rest and the source is moving with a velocity vs, velocity of the source, towards the observer at the rest. Then you know this frequency of the sound, that was, let's suppose that was the 30 hertz, for example, that one is a 30 hertz. If they both are in the rest, source and observer both are in the rest, then the observer will perceive the same frequency 30 hertz. But if it's moving with the velocity vs towards the observer, you know what happens? Frequency of observer, apparent frequency, which the perceived by the observer, will be greater than the actual frequency. It will increase. And when this observer is in the rest and the source moving away from the observer with the velocity vs, and let's suppose its frequency was 30 hertz again, when it's moving away, it means again the apparent frequency is going to decrease. That means in this case the apparent frequency will be less than the actual frequency. So you got that one. I have explained the two conditions. One, when the source is in the rest, observer is also in the rest, then both actual frequency and the apparent frequency will be equal. But if the source is in the rest and observer is moving towards the source, then the apparent frequency will increase. And when the observer is moving away, then the apparent frequency will decrease. In the same way, if the observer is in the rest now, and the source is moving towards the observer, then again the frequency, apparent frequency will increase. And when observer is in the rest and the source is moving away from the observer, then the apparent frequency will decrease. So one more case, that when the both are moving towards each other or both are moving away from each other, then again there is apparent change in the frequency. When moving towards each other, the frequency, apparent frequency will increase. When moving away from each other, then the apparent frequency will decrease. So this change in apparent frequency is because of the motion of the observer or source or both. So this phenomena is known as Doppler effect. So students, note the point. First, Doppler effect, when we go through the introduction, when there is a relative motion, when there is a relative motion between a source of the sound, between a source of sound and listener, then pitch changes frequency observed by listener will also change. So this effect was first observed by an Australian physicist and Australian physicist C.J. Doppler. That's why this effect is known as Doppler effect. So I think you have got this one. So due to the relative motion of observer or source or both, there is an apparent change in a pitch of the sound. Because of the change in a pitch, the frequency will also change. Frequency of the sound will remain same, but the frequency of that sound which is being observed by the observer will appear to be changed. That's known as the apparent frequency. This phenomena is known as Doppler effect. So now when we go through the proper definition of the Doppler effect, we can define Doppler effect. The apparent change in the pitch of the sound, of the sound caused by relative motion of observer, source or both is known as Doppler effect. There are three different possibilities for the Doppler effect. There are three different possibilities for Doppler effects, or you may say there are three possible conditions for the Doppler effect. Number one, when source is at the rest and observer is moving. Second condition, when observer is at the rest and source is moving. And the third possibility, when observer and source both are moving. So dear students, we will continue our topic. We have the three possibilities for the Doppler effect. So the first one, case 1a, when observer is moving towards a stationary source. It means your source is in the rest and observer is moving towards the source with the velocity v naught, moving towards the source. This one is the source, this one is source, and this one is observer or listener. When this observer is moving towards the stationary source, then what will be the change in our apparent frequency? We are going to derive the formula for that. So this source, when this source is producing the sound, let's suppose, for example, consider a source of sound, consider a source of sound emitting sound waves of frequency f with velocity v and wavelengths lambda. Then wavelengths of sound waves is given by lambda is equal to v upon f. So this is the relation for the wavelength of the sound. I already told you, when there is apparent change only in an apparent frequency, not in the sound speed. So lambda is equal to v upon f. Now if the observer is also in the rest, that means that with the same frequency f, the sound will reach. That means the actual frequency will be equal to apparent frequency. But if the listener is also at rest, then sound will reach the observer with a speed v, but if observer is approaching to source with velocity v naught, then the speed of sound, reached observer will be v plus v naught. So then thus the frequency of the sound perceived by observer will be f prime, and it is given by f prime is equal to v plus v naught over f over lambda, sorry. So it is given by f prime is equal to v plus v naught over lambda. Putting value of lambda in equation, we have f prime is equal to v plus v naught divided by v over f. Rearranging that one, f prime is equal to v plus v naught over v into f. So in this equation, you know that as the numerator of this frequency is going to increase, that means the apparent frequency will also increase. This shows that apparent frequency will increase. So that one is a case 1a. When source is in the rest, observer is moving towards the stationary source, what happens? The apparent frequency appears to be increasing, and the formula for the apparent frequency is f prime is equal to v plus v naught f over v. So this shows that whenever observer moving towards the stationary source, the frequency appears to be increasing. And now, when we start the second case, case 1 and its B part. Now, we are going to start case 1 part B. So in this case, now we have case 1 again and its B part. When source is stationary and observer is moving away. Now in this case again, when the listener or the observer is moving towards a stationary source, you know that. When the listener moves away from the stationary source with a speed v naught, like let's suppose this one is the source of the sound and this one is the observer, this one is the observer. If let's suppose this sound reach here with a velocity v, the velocity of the sound is, this one is the source, velocity of the sound is v. When this observer moving away, that means moving away with a velocity v naught, then you know that there is a decrease in the apparent frequency. Whenever the observer is moving away, there is a decrease in the apparent frequency. When both are at the rest, then sound waves approach to observer with velocity v, but if observer is moving away from stationary source, then velocity of sound received by observer will be v minus v naught. If f prime is the frequency received by moving observer, then it is given by f prime is equal to v minus v naught over lambda. Again, putting the value of lambda in equation, we have lambda prime is equal to v minus v naught over v over f. We know that lambda is equal to v upon f. Then f prime is equal to v minus v naught over v into f. So this is the formula for the apparent frequency when the observer is moving away from the source. So when you look at this formula, there is a decrease in the numerator, that means the overall result will decrease. This shows that this equation shows that apparent frequency observed by moving observer away will decrease. Dear students, now we are moving to the case 2, part A, and we have already discussed. Now, in this case, observer is in the rest and the source is moving towards the observer. So, case 2 A, when source is moving towards a stationary observer. Now in case 2A, now look at this one. This observer is in the rest, but this source which is producing the sound, this one is moving towards a stationary source with a velocity Vs, velocity of the source. As you know that. The sound have the same velocity, but remember one thing. Now the source is moving towards the stationary observer. It means there's a certain change in the wavelength as well. How? Look at this. Where if the source moves, with stationary observer with a velocity Vs, then the wavelength of the sound waves will decrease, then the wavelength of the sound waves will decrease, and the new wavelengths lambda prime is given by lambda prime is equal to V minus Vs over F. So as the wavelengths and frequency are inversely proportional to each other, so as the wavelength decreases, then the frequency will increase. So as the wavelengths of sound waves observed by listener decreases, hence frequency will increase. Now the prime frequency f prime is equal to v over lambda dash. So putting the value of lambda prime, so f prime is equal to v over, put the value of the lambda prime from this equation, v minus vs over f. So f prime is equal to v over v minus vs into f. So this is the equation for the apparent frequency when the source is moving towards the stationary observer. So dear students, as you know that there is a decrease in a denominator, then the overall result will increase. This equation shows that apparent frequency will increase when the source is moving towards the stationary observer. Now, dear students, again the case 2, its B part. Now it's very easy for you as well. When observer is at rest and source is moving away. Dear students, you know that if the source moves away from the stationary listener, if the source is moving away from stationary observer with velocity vs, then there will be increase in wavelengths. There will be increase in a wavelength, and the new wavelength and the new wavelength lambda prime is given by, so lambda dash is equal to v plus vs over f. You know, this shows that the apparent wavelength is going to increase as it's inversely proportional to the frequency. That's why the frequency will decrease as the wavelength increases. As the wavelength increases, the apparent frequency will decrease for observer. It is given by f prime is equal to v over prime lambda. So putting the value of lambda prime in this equation, we have f prime is equal to v over, put the value of the lambda prime from this in that equation, then f prime is equal to v over, putting the value of this one from v plus vs over f. So you may write here f prime is equal to v over v plus vs into f, and this one is the formula for the frequency which is being observed by the observer when observer is in the rest and source is moving away from that. This shows that this equation shows that apparent frequency decreases when the source is moving away from the stationary source. Now we are moving to the third case, case 3a. Now case 3a, when source and observer both are moving towards each other. Now when the source and observer both are moving towards each other, so you know that if the observer is moving with velocity v naught towards a source, then its frequency will change from f to f prime, and it is given by f dash is equal to v plus v naught. We have already done this one, divided by v into f. Let's suppose this equation number 1. This one is the change in a frequency because of the motion of observer. If source is also moving with velocity vs towards observer, then its frequency will change from f prime to f double prime. It is given by f double prime is equal to v over v minus vs into f dash. Putting value of f prime from equation 1, we have, look at this, f double prime is equal to v over v minus vs. This f prime is equal to what? V plus v naught over v into f. When we put this value, what happens? F double prime is equal to v will be cancelled. Now we have v plus v naught over v minus vs into f. So this is the equation when both are moving towards each other. Remember one thing. And now numerator, their addition means apparent overall result is increasing. There is minus in a denominator. That means overall result also increasing. It means this equation shows that when both are moving towards each other, the apparent frequency increases. This equation shows that apparent frequency will increase when both source and observer are moving towards each other. Now we are starting the B part of this case number 3, and that would be the last one. So case 3 part B, when source and observer both are moving away from each other. So this one's, when we go to start this case, this will be very easy for you now because we have already done the first part. So in this case, if the listener is moving with velocity v naught towards the source, then apparent frequency will change from f to f prime. It is given by, it is given by f prime is equal to, it's going away then, v minus v naught over v into f. Let's suppose this equation number 1. Now, if the source is also moving with velocity vs towards the observer, then frequency will further change from f prime to f double prime. It's given by, it is given by f double prime is equal to v over v plus vs into f prime. Putting the value of f prime from equation 1, we have f double prime is equal to v over v plus vs, and this f prime, its value is v minus v naught over v into f. Put the value, that would be v minus v naught over v into f. So this v will be cancelled. Now f double prime is given by v minus v naught over v plus vs into f. So this is the equation when both are moving away from each other. It means from this equation it's very clear that what, as this minus on the numerator shows that overall result is going to decrease, and this plus at the denominator is also showing that the overall result is going to decrease. This equation shows that this equation shows that apparent frequency decreases when source and the observer both are moving away from each other. So that was our topic, Doppler